Dear students, today we will discuss about the chemical properties of alcohol. See, when we are talking about the chemical properties of a particular organic compound, it is the property of the functional group present in that organic compound. The chemical behavior of a particular class of organic compound depends upon the chemical behavior of the functional group present. So, if we are aware about the behavior of the functional group, then it will be easy to understand the chemical properties of a particular organic compound. So, in case of alcohol, we have the functional group OH. See, OH, attach this carbon and this carbon attached to 3 bonds. So, already in the very first class of this chapter, we have discussed the nature of this functional group. We have seen that this CO bond is polar minus, and also this OH bond is polar. Because this CO bond is polar, the OH bond is polar, so what? The chemical behavior of this alcohol depends upon the CO bond and OH bond. So, the chemical reactions of alcohol is given by either the breaking of the CO bond or also it is because of the breaking of OH bond. So, some chemical reactions are there which are due to the breaking of the CO bond, and some chemical reactions of alcohol is there which are due to the breaking of the OH bond. Besides these also, some chemical reactions of alcohols are there which are due to the involvement of the entire group, the OH group and also the alkyl group. So we have 3 kind of chemical behavior shown by this alcohol class of organic compound. Number one is what? Reactions due to OH bond breaking. Number 2, reactions due to CO bond breaking, and number 3, reactions due to both OH and alkyl group. Now let us discuss the chemical reactions of alcohol due to the OH bond breaking. Okay, here you see, when I have this alcohol class of organic compound, here you see this oxygen atom is having 2 lone pairs of electron, and this species can be had as a nucleophile. We know nucleus are having electron efficient centers. So in this case, this is the electron efficient center. So this can behave as a nucleophile, nucleus loving species. When I have Sc plus. This is an electrophile. Okay, there will be an attack. Of this nuclear center to this center. We will get what? C S C plus. Now this species is having a positive charge, so this becomes unstable. This will give this one. So we get what? C O C. This is your product. So in this kind of reaction, so this OH bond is breaking. OH bond is breaking, and we are getting this product. Here you see, when there is the breaking of this OH bond, the strength of this OH bond depends upon the number of alkyl groups present in this carbon. See, when we have in this carbon, we have more number of alkyl groups, suppose 1, 2, 3 alkyl groups are there. Now these alkyl groups are having the plus I nature, electron release. When they release electron, here the electron density on the oxygen atom increases. And this helps the oxygen to attract the proton more easily. So the proton or the heteron cannot detach from the species. So the bond becomes stronger. Because the bond is not breaking easily, that means the reactivity of the species becomes less. So more the alkyl group, less is the reactivity, less is the possibility of breaking of this OH bond. When we have less number of alkyl groups, so if only one alkyl group is there or only hydrogen atoms are there, then this center becomes less negatively charged. So the chance of detachment of this OH bond becomes more easier. So what we can say, the CH3OH is more reactive than your primary alcohol, is more reactive than secondary alcohol, is more reactive than tertiary alcohol. Whenever there is breaking up of OH bond, the OH bond breaking facilitates with the less number of alkyl group attached to the carbon to which the OH group is attached. More the alkyl group, less is the reactivity. Less the alkyl group, more is the reactivity. So in this kind of reactions, primary alcohols are more reactive than secondary alcohol, then tertiary alcohol. Okay, so let us discuss different kind of examples showing this kind of reactions. Okay. This is equanite, reactivity of alcohol. Okay, remember, reactivity of alcohol to this particular type of reactions. When OH bond is breaking, there the reactivity is more for methyl alcohol, then primary alcohol, then secondary alcohol, then tertiary alcohol. Okay. Now, let us have an example of reactions having OH bond breaking. Example, reactions with active metals or metal hydrides or metal hydrides. So how these alcohols are reacting with the metals or metal hydrides? If I take Ca3, Ca2, OH, alcohol plus sodium metal, I'll get what? Ca3, Ca2, ONA plus H2. Ethyl alcohol or ethyl alcohol is called your sodium ethoxide. So when ethyl alcohol react with active metals like sodium, potassium, magnesium, calcium, then corresponding alkoxides are formed. If I take ethyl alcohol, react with sodium metal to give you sodium ethoxide. So here one thing we can observe that Ca3, Ca2, OH gives C2, Ca2, ONA plus H2. That means the hydrogen atom here is replaced by sodium atom. So any species who can replace a hydrogen atom by a metal atom can be considered as an acid, because in this alcohol the hydrogen atom is replaced by the sodium metal, so this is an acid. So this reaction shows the acidic property of alcohol. But one thing we have to remember here, though this ethyl alcohol or generally alcohol replacing the metal atoms by hydrogen, they are acidic but are not strongly acidic. There are very weak acids, even if they are less acidic than water. This is the reason that the alcohols, though acidic, even if they are not reacting with bases like KOH, NaOH and sodium bicarbonate. Because of this less acidic nature of alcohol. So similarly, I can take Ca3, Ca2, OH plus NaH, sodium hydride, can give what you Ca3, Ca2, ONA plus H2. Same thing, ethyl alcohol, whatever, sodium ethoxide. So what happens here? The OH bond is breaking. You can see here, the OH bond is breaking. Okay? Now to this O, the sodium is attached. Now H becomes H2. Okay? Similarly, the next type of reaction, reaction with Grignard's reagent. Reaction with what? Grignard's reagent. We know what are Grignard's reagents? Grignard's reagents are alkyl magnesium halide. So when alcohols are reacting with alkyl magnesium halide. For example, if I take CH3 MgBr, this is your ethyl alcohol. What is your ethyl alcohol? Is your methyl magnesium bromide. OH bond breaking. Okay, as possible. Here what is CH3 MgBr? We know CH3 minus MgBr. Okay, so what we get here? CH3 minus then has CH4 plus CH3 CH2O MgBr. Methyl. So what we are getting here, when ethyl alcohol react with methyl magnesium bromide, then methyl is formed. So what you can say, alcohols when treated with Grignard's reagent alkyl magnesium halide, then alkane will form. And you remember here, the alkane formed is from the alkyl group of the Grignard's reagent. Remember it. We cannot take this alkane from this one. Okay, because we are going to break the OH bond. The OH bond breaking. Now this has attached to the alkyl group of this Grignard's reagent. Okay, accordingly, the presence of alkyl group in the Grignard's reagent, the alkane will be formed. So here CH3 is CH4. Okay, so this is also one of the example how this OH bond is breaking in alcohol to give the product. Okay. Now, next is one reaction with carboxylic acids. Okay. Now see, if I take CH3, CH2OH, ethyl alcohol, Now plus if I take carboxylic acid, HO, C double bond O, C3, called your acetic acid. Okay. Now H plus. In the presence of mineral acid, alcohols react with carboxylic acid to give what? See, there will be OH bond breaking and there will be the acyl oxygen bond breaking. Right? They get what with it? Water plus CH3, CH2, O, C double bond O, CH3, or what one? Ethyl acetate. So, because we are dealing with the breaking of the OH bond, remember here, the OH bond of the C alcohol is breaking, and the CO bond of the carboxylic acid is breaking, and there is removal of water molecule, and we are getting what? Stop. So, whenever alcohol is treated with the carboxylic acid in presence of mineral acid, we are getting what? Stop. And this reaction is a reversible reaction. This is called what? Esterification, because it is formed here. And the reverse reaction is called what? Hydrolysis of ester. Now, the next video, how this OH bond making happening in case of acid chlorides and acid anhydrides. Listen to acid chlorides and acid anhydrides. Okay, see, CH3, CH2OH. Okay, plus acid chloride, Cl, Cl1O, CH3. CH3, Cl1O, Cl. OH bond making, we will have acid. Okay, in place of a pyridine base, we will have CH3, CH2O, Cl1O, CH3 plus acid. In what? Ethyl acetate. So what you can say? When alcohols are treated with acid chlorides in presence of pyridine base, is catalyst, then esters are formed. So we have seen here ethyl alcohol reacting with acetyl chloride in presence of pyridine base to give what? Ethyl acetate. See here, this is what you call ethyl alcohol. Here acetyl chloride, ethyl acetate. Okay. Similarly, also we can do the same type of reactions with the acid anhydride. So if I take CH3, C-O, C-O, this is called what? Acetic anhydride. Called what? Acetic anhydride. Okay? Plus, if I take HO, C2, ethyl alcohol. What? Ethyl alcohol. Pyridine base. Now what? OH bond making. Okay. So we get what? Okay. So here CH3, Cl1O, and O secures fine plus CH3, Cl1O, OH. You get what? CH3, C-O, OH plus CH3, C-O, OC2H5. One ester and one acid. Ethyl acetate and zero acetic acid. Okay, so in this way we are getting esters from the acetic anhydride. So these are the 4 different examples of how the alcohols are reacting with the breaking of OH bond. So first of all, we have seen how the OH bond is breaking and that is reacting with the sodium metal. Then we also have seen how it reacts with sodium hydrides. Then we have seen how this alcohol is reacting with Grignard's reagent with the involvement of OH bond breaking. And also we have seen how this alcohols are reacting with the carboxylic acid, acid chloride and acid anhydride, which involvement of OH bond breaking to form esters. So next we will discuss is what reactions involving the breaking of CO bond. Okay. So number two, your reactions due to CO bond breaking. Okay.